Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. Students, in this class we are going to learn the applications of gravitational potential energy, and you should know very well the basics of the mechanical energy that we are going to learn to solve the questions of the applications of gravitational potential energy. So see here students, the topic is basics of mechanical energy, and you know very well mechanical energy is the sum of kinetic energy and potential energy, and in this chapter we are talking about specifically gravitational potential energy. Okay, second one, mechanical energy of any system remains conserved if work is done by only which force? Conservative force. And you know very well gravitational force is the which force? Conservative force. Okay, third one, students, see please, at infinite distance away from the planet, that means in interstellar space, potential energy of the projected body will be how much? Zero, because what will happen? The body will go outside of the gravitational field of the planet, and there what will happen? Its GPE will become zero, and that is the maximum possible value. Otherwise all the places GPE is the negative that we have learned. Next one, students, see please, in interstellar space, minimum kinetic energy of the projected body will be how much? Zero, minimum, because when we are projecting the body with the escape speed, that time only energy will be zero. But if you are projecting the body more than the escape speed, then what will happen? You know, in interstellar space energy will not be zero, it will be more than zero. Okay, that we are going to learn, but as of now we have to remember that minimum kinetic energy how much in interstellar space? Zero. Next one, in interstellar space, minimum mechanical energy of the projected body will be also zero, because potential zero and minimum kinetic energy is zero. That means minimum mechanical energy will be how much? Zero. Okay students, now let's go to the application. So see here please, work done to lift an object above the surface of planet without changing kinetic energy. So if the kinetic energy is not changing, whatever work will be done, that will change the gravitational potential energy. Okay, so let's see one by one. So here I have taken my planet is there, mass m, and the radius of the planet how much? Radius of the planet is r. After that, students, here please, here I have taken 1 point mass small m at the surface. Now, so what will happen that here, as the point mass is on the surface, the total mass of the planet can be concentrated at the center. Here is small m, and this distance to how much? Capital R. That means in this situation, initial potential energy of this system is given by formula minus G capital M small m by R. Now, equation 1. Now students, GPE of the object at height h above the surface of the planet is given by how much? So again, now what is happening at here? This is my planet, as I told you very well, is it? Now what will happen? Now the object is here. How much height? H height. H height. Okay. So here what will happen that students? Let's see please. Again, the total mass of the planet can be concentrated at the center, and here I have small m. Now can you guess very well what is the distance between capital M and small m? This value is the R plus H. Now, so in this situation, the final gravitational potential energy is given by minus GMM R plus H. Okay, this one we have got it. Now students, we have to calculate the work done. So as you know very well, the kinetic energy is not changing. So what will happen? Whatever work will be done, that will change the gravitational potential energy. Okay, so in this situation, just here please, work done by external force or change in GPE is given by, students, let's see here please here, work done by the external force or change in GPE is given by UF minus UI. What is UF, students? Minus GMM by R plus H minus. Okay, and again what is UI? Minus GMM by R. Now after that what will happen that here? We will take the sum of the things common. So GMM is common, it will become here 1 by R minus 1 by R plus H. Okay, after that what will happen? We will take the LCM. So after taking the LCM, what will happen? See please, R into R plus H, and here when you will take the LCM, it will come H. Now what we'll do here? here we will multiply with r, and here we will divide with r. Why we are doing this? Just to simplify this more. So here what will happen that now in this situation, this work done will be, students see please, we can write here this gm, this r together, is it? So this one is coming as what? Gm by r square. Okay, this small m I have kept it here. Now what other things are left? This r is left, this r plus h is left. We'll write here r by r plus h. Okay, and after that, students, one more, what is there? This h is pending. Now, so students, you can see here please, this is m. What is gm by r square? G. And what is this h? Now this h I have written here. Now r by r plus h, what can I write here? I can write here r plus h by r, is it? Hence work done by external force is given by mgh by 1 plus h by r. Okay, so this is our general formula. Work done by the external force, even change in a GPE also, same story will be there. Okay, students. Now after that, we'll see some cases. What is the case one? If h is less than r. So if h is less than r, what we can tell here? H by r is less than 1, and approximately we will consider how much? 0. So in this situation, work done by the external force will be how much here? We know very well, mgh by 1 plus h by r. That means it will come here how much? This will come here mgh. Okay, so whenever the object is near to the surface of the planet, mgh value that we have learned before also, is it? Now after that, what will happen? That next one, students see please, case 2, if h is equal to how much? nr. So in this situation, see please, work done by the external force will be given here mgh by 1 plus h by r. So from here, h by r, how much here? See please, this h by r will become here 1. So 1 plus n. And even if we write the value of h equal to nr, then what this will become here? See please, n by n plus 1 into mgr. This value, h I have put nr, and we have got this formula, remember that. Okay, students, so in a NEET exam, from this area, question used to come regularly. Now, I hope so you have understood very well. Now we are going to learn the next application, that is also very important. What is this? Velocity required to project an object above the surface of planet. Okay, so see here please, here let an object is projected with speed u from the surface of a planet, and its instantaneous speed is 0 at height h, as shown in diagram here. Okay, so students, so see here I have taken one diagram. Now planet is there, mass m, radius r, and what is going to happen? We are going to project from here. We are going to project from here with speed u. Now mass is m, and what is happening that here at height h, is speed is becoming how much? 0. So you know very well, as the object is moving under the gravitational field only, and gravitational field is the which kind of force? Conservative force. That means what will happen here? The energy of the system will be conserved. Okay, so if I take here this point A and this is point B, then what will happen? We can see as work is done by only conservative force, hence mechanical energy of the object is conserved. So mathematically, what we can write here, students, see please, we can write here energy at point A and energy at point B will be same. Now energy at point A means potential plus kinetic. Similarly, energy at point B also, how much it will be there? Potential plus kinetic. Now after that, at the surface of the earth, what is the value? We know very well, minus g mm by r. And the kinetic energy, how much here? Half m u square. Now at a height of h, potential energy how much? Minus g mm by r plus h. And instantaneous speed, as we have seen, how much? 0. So this one we have got this here. Okay, now after that, what will happen that here? We will just simplify this here. Okay, so what will happen, students, here please, here we can write here this one, half mu square is equal to, we can write here, minus g mm by r and minus g mm by r plus h. Okay, we will just see it back side. We are going correct here. Now, so this is g mm by r plus h, and this one will go and that will become plus. Okay, so this will be plus here. And before also we have simplified this, and after simplification, what we have got that in the previous case, mgh by 1 plus h by r. Okay, now what will happen, that students, see please here, this m, and this m will cancel out. That means what we can write here? We can write here u equal to 2gh by 1 plus h by r, and here this square root. Okay, this is the speed, we have to throw it. After that, here just the reverse situation, because there is no air resistance, nothing. So ascent situation and descent situation both will be what? Symmetric. So we can write here, see, similarly, if the object is dropped from height h, then it will hit the earth with the same speed v. Which same speed here? See please, here from here we have dropped here u equal to 0. It is falling and it is going to hit with the speed v. Now here our planet is there, as we have seen that. So in the reverse way, what will happen that here, with whatever speed we have thrown, now and we have got u, in the reverse also will happen same thing. That means what I want to tell you, in this situation also the value of v will be root 2gh 1 plus h by r, because you know very well, in the absence of any air resistance, ascent and descent situation is the very similar situation here, na? Okay, next one. So after the students, let's see the cases here. If h is less than r, and as I told you very well, h by r will be what? Approximately 0. In this situation, this u will come here root 2gh. Okay, similarly here, if h equal to nr, that means h by r equal to n. You know the formula. What is the formula? Root 2gh 1 plus h by r. Just put the value of h equal to nr here. What you will get here? You will get u equal to formula n by n plus 1 into 2gr.